Another property of a graph that we're interested in is something called end behavior. Now, a lot of times this is also framed as a question as, does the graph have any horizontal asymptotes? But I'm just going to give it the generic, what's happening to the ends of the graph? So the idea for this is, generally we look at a graph somewhere around the origin. But what's happening to the graph as we head out towards infinity or towards, say, negative infinity? So if we were to look at, say, our friend the parabola, right now we were to say, what happens to the graph as we head to positive infinity? Well, it heads up to positive infinity. As we head towards negative infinity, it's heading towards positive infinity. Now, we've also seen graphs that look something like this. They may have a horizontal asymptote, where they may look something like this. I don't know, let's say that this is y is equal to 1, that dotted line. So as I head out towards positive infinity, it's heading down towards y equals 1. And over here, if I head towards negative infinity, it's heading up towards a y value of negative 1. In this case, if it's heading towards a specific value, it's called a horizontal asymptote. If it's heading off to an infinity, it's just called end behavior. But we can find both of these by doing the exact same thing. So to find end behavior, of a graph, look at the limit as, I'm just going to say x goes to both positive and negative infinity. All right, we're just going to take a couple of quick looks at this because we've already done limits at infinity in the past, so these shouldn't be too difficult, but we are going to do a few that we may not have seen in the past. So let's take a look at this. So I'm going to say just find the end behavior. So if we have the function y is equal to x squared plus 3x minus 4. If I'm just talking about the end behavior, I'm talking about what happens as we head out towards our infinities. So really what I want to do is I want to find the limit as x goes to positive infinity and the limit as x goes to negative infinity of this function. Now we've seen in the past, when we're heading out towards an infinity, the lower terms really don't matter, right? Because think about it, this is going to be infinity squared plus 3 times an infinity minus 4, right? The minus 4 doesn't mean anything. In fact, all lower powers basically don't mean anything at all. So as we head out towards, I'm going to actually get that one out of the way for right now. This is going to look like just the limit as x goes to infinity of just x squared. So now kind of mentally picture what's happening. Infinity squared, of course, is going to be infinity. Now, is it positive or negative? Well, as we head out towards infinity, we're heading towards positive numbers. Positive numbers squared are still positive numbers, so this heads out to positive infinity. I'm going to move our second question over here. If we do the limit as x goes to negative infinity, x squared plus 3x minus 4, we're going to do the same method. This really starts to look like, or starts to behave like, the limit as x goes to negative infinity of, well, x squared again. Now this time we're going to negative infinity, which means all of our numbers are negatives. However, a negative squared is a positive, so this is still heading towards positive infinity. Now this answer we should have already known because we know what the graph of this looks like. That's just a quadratic, which means it's a parabola somewhere. That's not where it's at. I'm just kind of doing quick up there. So we know that both ends, in this case, since our v coefficient is positive, are both heading up. And you notice that's what we got when we did the limit. All right, let's try a couple more. What if I said, find the end behavior of 4x minus 3 all over x squared plus 5x plus 1. Now this is a rational expression, and we learned how to graph rational expressions in the past. And one of the things we looked for with a rational expression was the horizontal asymptotes, if it had any. Well, to do those, you might want to go back and look at your rules, But really all we gotta do is take a look at the limits. So let's do the limit as x goes to positive infinity, 4x minus 3, x squared plus 5x plus 1. Well again, this looks like the limit as x goes to infinity, 4x all over x squared. That'll reduce to just 4 over x. Now as x goes to positive infinity, that's a positive over a positive, so it's positive. It's getting smaller and smaller and smaller, so that is 0. We do the same thing for the negative limit, and the good news is 99.99% of the time the work over here is exactly the same as the work for our first one, just our result may be different. So this is going to be the limit as x goes to negative infinity, 4x over x squared. Limit as x goes to negative infinity of 4 over x. Now again, here we're going to have 4 divided by a negative number, so that's going to be negative, but x is still getting bigger and bigger and bigger, so this is getting smaller and smaller and smaller, so that is going to be 0. So this graph, as we head out towards positive infinities, heading towards the y-axis, and as we head towards the x-axis, and as we head toward negative infinity, it's also heading towards the x-axis. All right, let's look at one real scary one real quick. One scary one and we'll be done. What if I said our function was 2x over the square root of x squared plus 3? All right. Well, if we're asked to find the end behavior, we're going to do the same thing we've been doing. We're going to find the limit as x goes to positive infinity. 3. And the limit as x goes to negative infinity. All right, just like before, all lower terms aren't going to matter. So the tops, there's no more lower terms up there, so that just stays at 2x. But the bottom, that plus 3 is going to go away as we get bigger and bigger and bigger. So that's going to be 2x over the square root of x squared. Now here's where you're going to make a mistake. Remember, the square root of x squared is not x. It's actually the absolute value of x. Now, what value is this? Well, remember, x and the absolute value of x are basically the same number, right? Because they're both x's. The only way that they might be different is they might be different signs. But in this case, since we're heading towards positive infinity, both of these are going to be the same number and they're both positive, which means x over x is just going to be 1. So as we go to positive infinity, that's just going to be a positive 2. Here, we do the exact same thing. It gives us 2x over the square root of x squared. This is the limit as x goes to negative infinity, 2x over the absolute value of x. Now here's where it gets a little different. Now the x's are the same value, but they could be different signs, and this time they're going to be different signs, right? Now we're heading towards negative infinity with all negative numbers. But the bottom, we're taking the absolute value of it, which means it's the positive value, and the top is the negative. So it's like negative 6 over 6, which of course is just negative 1, right? So this x over the absolute value of x is always going to give me a negative 1, which gives me a negative 2. Now, we don't see a lot like this generally in a course like the one we're in right now. However, they do show up. Normally, for most of the things we're looking at, if we have a horizontal asymptote, it's the same in both directions. This actually has 2 different horizontal asymptotes, depending on which direction we're going. So there's our xy axis. Here's what it looks like. We have one up here at y equals 2, and one down here at y equals negative 2. Now, as we head towards positive infinity, so as I head out that way, by the way, this graph goes to 0. This thing heads up towards y equals 2. And as I head towards negative infinity, it's heading down towards y equals negative 2. So the graph actually looks something like that. Notice as we approach infinity from two different directions, we're actually heading towards two different values. Most of the ones that you generally are going to see, you only have one horizontal asymptote, but as you see, you can have two. So anytime you're talking about the end behavior of a graph, just take the limit as you go to positive infinity, see what happens. Take the limit as you go to negative infinity, see what happens.